Hi guys, there's a very cool video I want you all to see. So let's take a look at it. The guy's getting a lot of elevation because he has a lot of momentum, right? He has a lot of energy to go into that ramp and be able to turn his body like that. Unfortunately, the landing is not that great. All right, you don't even want to see this one, so we're gonna stop it right there. What's up, everyone? Today we are going to be talking about kinetic energy. This is Mr. G. Martinez, and this is your 8th grade science channel. All right, so let's get started. Yesterday we talked about potential energy, and we look at a bunch of examples of potential energy. So today that's what we're going to be looking at. Today we're going to be looking at kinetic energy, and we're going to be trying to go in as fast as possible since you guys been exposed to this in 6th grade. All right. So first of all, let's start by looking at the different types of kinetic energy that you guys have studied before. Like for example, we have mechanical kinetic energy, right? So mechanical is just combinations of all the potential and kinetic energy in one little section. Like for example, these pictures that we have here, you can see all the potential and kinetic energy combined. All right, there you go. Let's take a look at another one. That other one will be electrical kinetic energy. And just because the movement of the electrons that are moving through a wire are occurring, and that makes them a kinetic energy. Thermal or thermal energy, yes, that is also considered a kinetic energy. Radiant, due to the movement of the wavelengths or light wavelengths that travel throughout a medium. All right, and then we also have sound. So sound are also waves that travel through a medium. It can be through water, it can be through air, or different things. Now, we are going to be focusing on all the details of this type of energies later on in another lesson. So today, we are just going to cover very quickly saying that these are 5 different types of kinetic energy. All right, so let's move on. I want to keep or emphasize 2 things about kinetic energy. First of all, kinetic energy is the energy of motion, all right? Objects that are moving have kinetic energy. The second thing I want you to keep in mind is the faster the motion or the faster an object goes, the more kinetic energy it's going to have. I want you to keep those in mind because if you don't pay attention to those, you're really going to get confused later on throughout the lessons. So let's take a look at some of the examples that we have seen before that are related to roller coasters and different things that we have seen before, right? So let's take a look at this one. I'm gonna use my little pen over here, my magic pen. Now keep in mind over here that this is a roller coaster, and the roller coaster usually goes a lot longer than this, all right? So I'm just gonna stretch it all the way over here. Okay, I'm gonna try to draw this as good as I possibly can, all right? And here is going to be the continuation of this structure of your roller coaster. Anyway, so there you go. When we were talking about potential energy, we talk about that potential energy over here on the top, it was equals to 100%, right? Because that's the highest elevation. And then the lowest elevation area, your potential energy will be equals to 0% because there was no elevation anymore, right? But for kinetic energy, I want you to keep one thing in mind. Kinetic energy at the highest elevation is going to be equals to 0%. If there is no movement, that's the highest elevation area, is the opposite for potential energy, as you can see. So kinetic energy is 0%. And kinetic energy, as the object moves downward, the kinetic energy is going to be increasing. Increasing. There you go. All right. which was the opposite of potential energy, because remember, potential energy, as you were going down, potential energy was decreasing, but kinetic energy is the opposite, kinetic energy increasing. And that because we can see this that we learned before in this little sentence: the faster the motion, the more kinetic energy. So an object, when it's falling through this area, it's gonna be picking up speed. It's gonna go faster and faster and faster and faster and faster. And so therefore the kinetic energy is gonna be increasing as it goes down the ramp, all right? And so there you go. Let's stretch it a little over here on the side. All right, now we're gonna be looking at this part right here, where if we had another elevation or another hill on the roller coaster, what will happen if we know that the kinetic energy over here is equals to 100%, right? Because this is the lowest elevation area. That means the object picked up a lot of speed and it stopped picking up speed at this lowest elevation area. So the kinetic energy is 100%. So what happens to the kinetic energy as the object goes up the hill? All right, this is the cart of the roller coaster, and it's going up the hill. And as it goes down the hill, or I'm sorry, up the hill, keep in mind the object is going to be slowing down. And as the object slows down, this is going to be, or the kinetic energy will be decreasing, right? So it's going to be slowing down. So therefore, it's going to be decreasing. All right. Once it gets up to the hill, we can consider this that it's going to go back to 0%. Over here somewhere in the middle will be 50%. If this is the kinetic energy 100%, then this is 75%, and so forth and so on. It's going to be slowing down 25% over here until it gets to the 0. All right, so it's very simple. It's completely opposite to what potential energy was. Remember, potential energy, as potential energy was going up the ramp, that potential energy was increasing, right? But kinetic energy is the opposite. Kinetic energy decreases because the object slows down. It makes sense. As you go up the ramp, let's say you're riding on a bicycle, then you're going to be slowing down as you go up in a hill. It makes perfect sense. All right. All right, let's take a look at the pendulum. We looked at the pendulum before, but with potential energy, well, kinetic energy is going to be, once again, everything is going to be opposite, all right? So let's take a look at this. Keep in mind that if you were to drop this object from here, the pendulum, this is called a pendulum. If you drop it, then here, your kinetic energy, since it's not moving, you're holding it here to drop it, your kinetic energy is 0%, right? Because it's not moving, 0%. As the pendulum or this circle goes down, the speed is going to be increasing. So therefore, your kinetic energy is going to be increasing as it goes down, right? This is the lowest elevation. So right here, you will have your 100% because it's the lowest elevation. This is the area where the pendulum is actually going to stop picking up speed. So from here on, it's going to start slowing down as it goes up. So this is 100% kinetic energy, all right? And once it goes up to this section, then your object is going to start slowing down. So kinetic energy is going to be decreasing. And if you look about the potential energy, what we were doing on the previous lesson, then you will notice that everything is opposite. So be very careful when you do your assignment and your homework for today. All right. So let's move on to the next thing. And let's move on. All right, we got another example over here. This is the one that a lot of the students have a hard time with, right? This is a coil or a spring. Coil or a spring, I guess we can say. All right, so on this one, we are going to be looking also at kinetic energy. Remember, kinetic energy is the energy of motion. So if this one over here is at rest, that means it's not moving, right? So which means that your kinetic energy will be equal to 0% because it's not moving. It's just laying down on the floor, all right? After you push with your three-finger hand all the way over here to as far as you can possibly push him, then the coil or this spring is going to compress. And if it's compressed, your kinetic energy, if you're compressing this all the way down, your kinetic energy is equals to 0, right? It's equals to 0% because it's not moving. You're holding it down. But what happens if you let it go? If you let go the spring, this one is just gonna jump out, right? So what happens to your kinetic energy if you let go? Well, your kinetic energy makes sense. It's gonna move. It's gonna move very, very fast. So kinetic energy will increase when you let it go, right? When you take off your hand. Likewise over here on the top, okay? Let's say that you grab this end over here and then you stretch it this way. You keep stretching and then you stretch it as far as you can possibly can. And here you go. Here you got your three-finger hand, right? And my God, I did it backwards, but whatever. All right, so you're stretching as much as you can, and you hold them there. When you're holding, the kinetic energy is equals to 0%. But what do you think is going to happen to the coil when you release it and let it go? And if you thought that the coil was going to go back to the original state where it was before, then you are correct, which means that it's going to move, and it's going to move very, very fast. So we can say that if you let it go, your kinetic energy will increase also. All right? Any questions on those? Those are going to be important for your assignment that you're going to be working on your homework. All right? So let's go move on to the next thing. The next ones that we have is this, right? This is your bow and arrow, okay? And remember that this one here is at rest. Anyway, this is at rest. So I'm just gonna use the, all right. This one is at rest. So if it's at rest, that means your kinetic energy is equals to 0%, right? You're not holding it. Now, if you stretch it as far as you can possibly stretch, obviously your kinetic energy is still gonna be 0%. Because you're holding it, right? Obviously, your potential energy is going to be 100%, but we're not talking about potential energy here. We're talking about kinetic energy. You're holding it. But if you release it, then this string is going to try to go back to its original position in a very fast movement, and the arrow will actually be thrown or projected to the front, right? So your kinetic energy will be increasing when you release it or when you let go. Any questions so far? All right. I hope you guys are understanding this. This is completely different, is totally opposite to what potential energy was. All right. So for your assignment yesterday, I gave you an assignment about potential energy, and I believe this one was on page, this one was page 14, I believe. Page 14 in your composition book, right? All right, so on page number 14, you were supposed to do this. Now let me go and explain a little what you're gonna be doing on this, right? So that way you can work on this one. The instruction says to cut and paste. We already did that. To draw the illustrations, that's what you're gonna do. And under this that you have tape on your composition books, under it, you're gonna have to flip it and then write the answers underneath, all right? But over here on the top, you can do the drawings. So let's do some of these drawings right now. So for the drawings, it says here to draw the object without, that means with no potential energy. No potential energy. All right. It's going to be a roller coaster. So draw an object in a roller coaster. All right. I'm going to try to be more careful this time. Still came out ugly, but came out a little bit better. Anyway, this is your structure of the roller coaster. It's an ugly structure, of course, right? But over here on the top, oh, with no potential energy. Remember that if you don't have potential energy, it's gonna be the cart is gonna be here on the bottom as it goes down the ramp, right? At the lowest elevation, it has no potential energy, and at the highest elevation, it will have the max or the most potential energy. Now, this is potential energy, guys. All right, so keep that in mind. Now let's draw a roller coaster with the object with potential energy. All right, so once again, we're gonna, oh my goodness, will be over here on the top, and that will be it. All right, now describe the change of the object. How is the object changing? How are the two pictures changing? Well, I can say this, right? You can say that the object with potential energy has higher elevation. There you go. All right. So you can do the rest. Remember the pendulum? The pendulum is that. Let me see if I can do this again. I will do a straight line over here probably, and then I'll put the circle, and then I'll put the dotted lines and whatever, right? This is the pendulum. I don't know. I'm gonna leave this to you to see if you can draw what the pendulum is gonna look like with no potential energy, like it says right here on this area, right? And with potential energy. So it's your job to do your best. See if you can do this correctly. And also a rubber band, so I guess you can put a hand that is stretching. I'm not looking for anything artistic. It doesn't have to be perfect. Look at my drawings. They're not perfect at all, right? So that's what you're supposed to do. Let's move on to the next one. Okay, the questions are over here on the bottom. See those questions on the bottom? Yeah, those are the ones that you're gonna be answering underneath, all right? So what is potential energy? Get it from your PowerPoint that I sent you before through Remind, right? You also have it on your foldables, and I can't remember what page 11, I believe, right? How can you increase the potential energy of an object, right? Looking at all these lessons, see if you can answer that. Letter C, what happens to the potential energy of an object that is falling? Right? Answer those questions. Should be able to know it by now. Letter D, what happens to the potential energy of an object that is increasing its elevation, right, as it goes up a ramp? Okay. And letter E, what happens to the potential energy when a rubber band is stretched? All right. So those are all potential energies. That was the last assignment on potential energy that you were going to be doing. Now let's take a look at some of those kinetic energy assignments that you have for homework 2. Now you are familiar with this ones because you worked with something like this before, but now we switch it to kinetic energy. Take a look at figure number 1, all right? Figure number 1, let me get my drawing going. All right. Figure number 1, which is this one over here, right? And what percentage of kinetic energy is at point A? So the kinetic energy, what is the percentage of kinetic energy at this point? We know is 0%, right? So we are going to be answering the questions underneath the flip just like before. A hard time with this one's on the top, like figure number 3, which area, I'm sorry, has no kinetic energy. And if you look at all three, okay, this one is at rest, so this one doesn't have any kinetic energy. This one is being compressed, it's being compressed. Remember, if you're holding it, it has no kinetic energy. So this one doesn't have kinetic energy. Now the next one, letter C, this one is being stretched and it's being held on the stretch. So you can tell that this one also doesn't have any kinetic energy. So your answer for question number 1 is none of them. None of them has kinetic energy. All right, let's take a look at question. And then at the end, you have this kinetic energy examples that you're supposed to be working with. And pretty much as the previous one on kinetic energy. All right, so guys, I know it's a long video. I hope you follow through and I hope you guys understand what to do on this one. If you don't understand, make sure you send me a text on Remind, and I'll be more than glad to try to help you, right? So keep up the good work. You guys are doing fine. We'll see you guys later. Take care. Do all your homework and do it right. Do it right. Absolutely. Bye bye now. Don't cry now.